Let us make a study on optics. Optics, as you know, it is the scientific study of sight and light. It is a chapter comes under physics. Since you are studying the optics from the high school, let us concentrate on the syllabus of class 12 physics. Before commence the study of optics, before you go for the study of optics, let me brief about the electromagnetic radiations. The electromagnetic radiations. The electromagnetic radiations, you have heard of the names gamma ray, X-ray, UV ray, visible light, IR, infrared, microwave, radio wave. All of them are called as electromagnetic radiations. We have classified them into 7 different electromagnetic radiations. What is the meaning of electromagnetic radiations? Electromagnetic means there is electric field and magnetic field. This electric field and magnetic field are variable, both of them are variable in magnitude and direction. The variation is, it is in periodic variation, just like sinusoidal wave. That is sinusoidal wave, a periodic or symmetric variation. Two electric fields, that is electric field and magnetic field, are oscillating just like a sinusoidal, and always they lie perpendicular with each other. The oscillations, electric field and magnetic field lie perpendicular to each other. There is a diagrammatic representation of electromagnetic radiation. That is x coordinate, y coordinate and z coordinate in the perpendicular direction. One wave is oscillating in the direction of y, that is this is the one orange color, and other wave is oscillating in the direction of z axis, that is perpendicular to the blackboard, board. If you call one as electric field, other as magnetic field. So this is electric field, other as magnetic field. That they mutually induce us with each other. Electric field induces the magnetic field. Magnetic field induces the electric field. These oscillations produced due to mutual induction between electric field and magnetic field, which are variable in the form of sinusoidal wave. Both the waves are same, but in the perpendicular direction. And they will not stand still always. These waves are propagate or travel in straight line along the axis, x-axis. That is, propagation is in the direction perpendicular to magnetic and electric field oscillations. The oscillations are perpendicular to each other and the propagation is perpendicular to both, propagation along axis. That is traveling at the speed of light. These electric field and magnetic field oscillation, electric field oscillation and magnetic field oscillation, that is variation like this, sinusoidal wave, one wave, there is another wave of magnetic. These waves are always coupled together, very important. These oscillations are always coupled together while they are traveling in space. Mutually induces, they are always coupling together. magnetic electromagnetic. So this is called as electromagnetic radiations, and they travel in space at the speed of light, and the transmission of this electromagnetic radiation in space doesn't require any supporting medium in empty as well as in the gas or any medium it can travel. And this electromagnetic radiation is an energy carrier, carries energy from one point to other point in the space, anywhere in the space, anywhere in the universe. These electromagnetic radiations are the source for these radiations are the sun, mainly the sun and stars. Sun and stars are the sources of these radiations. The sun emitting all these radiations, we have these radiations in the space. This magnetic and electric field. And the classification is based on the wavelength or frequency of the radiations. That is characteristic properties, wavelength and frequency. What is wavelength? Wavelength is the length of one wave. It is varying from one type to other type. Or frequency. What is frequency? Number of such waves passes a point in 1 second. In 1 second, how many waves are passing through a point? That is called as frequency of radiations. Frequency, wavelength, or inversely related. On the basis of this, either wavelength or frequency, we are classifying these radiations. Not one single, it is a range of wavelength or frequency. If the range of wavelength lies in between 10 to the power of minus 3 to 10 to the power of minus 2 nanometer, that is a nanometer scale, 10 to the power of minus 9 is a nano. If the length is so small, that is a wavelength of the radiation, that is a mixture of waves. Is a mixture of not one single wavelength, mixture of wavelengths. So this range of wavelength, they are called as gamma ray. Classification is depends only on the wavelength or frequency. All radiations are same, there is no difference. That is oscillation of electric field or magnetic field. They are coupling always each other and traveling in perpendicular to each other. But difference is wavelength difference or frequency difference. If the wavelength is 10 to the power of minus 2 to 10 nanometer, that is even the little higher wavelength. Higher wavelength, this is called as X-ray. This range of waves is called as X-ray. And another range, 100 nanometers to 400 nanometers, is a mixture of waves. Of this wavelength, it is called as UV rays. It is called as UV rays. And another one, if the range of wavelengths lies between 400 and 700 nanometer, this mixture of waves, it is called as visible light. Visible light, this is the one we have to concentrate this. Electromagnetic radiation of this wavelength is called as visible light. And the next stage is 700 nanometer to 1 millimeter. This nanometer changes to millimeter. Millimeter is higher scale. 1 millimeter, it is known as IR radiations, infrared radiations or heat radiations, thermal radiations. And the wavelength between 1 millimeter to 1 meter, is even bigger, 1 meter up to 1 meter, that radiations is called as microwave. And between 1 meter to 100 meter, the radiation is called as radio wave. All these electromagnetic radiations are similar, no difference at all. But difference is wavelength or frequency difference. That is coupled oscillations. What oscillations? Electric field oscillation and magnetic field oscillation. They always coupled together and travel together in the space. Electric field and magnetic field. That is a variable electric field, variable magnetic field coupling together and travel in the space carrying energy. Energy from one point to other point. So when you talk about this electromagnetic radiation, whenever you represent these radiations, you take any one of the wave, either electric field or magnetic field. There is an oscillation like this. And this wave has energy, and we have to specify the amount of energy of the wave. It is by using the equation, Einstein's equation, E is equal to h nu. C by lambda in terms of wavelength or in terms of frequency, this value. Where Planck's constant is velocity of the radiation. Electromagnetic radiation 10 to the power of 8 meters. And if you calculate that is what amount of energy, if the radiation or wave like this possess this amount of energy, that is E, and that is called as, it is designated as a particle, single particle, or it is a discrete particle. Every wave is a discrete, just like a discrete particle. It is a single particle or one photon of radiation. One photon of radiation, that is. What is one photon of radiation? One photon of radiation is the wave, electromagnetic wave, which possess this amount of energy. This is a calculation like this. That is called as particle, behaves like a particle, exactly that wave, that is called as a packet of energy or packet of wave, a photon of wave, exactly behaves like a particle, just like electron particle or atomic particle. So that is why it is called as a discrete particle. Wave and particle have a dual character, wave character and particle character. Here you can treat this wave of this amount of energy is called as one photon of radiation. And when you talk about, that is a beam of radiation, that is a ray of radiation, that beam of radiation consists of multiple photons. That is, multiple means I say in billions of photons. If you consider a beam of radiation, whether a beam of gamma ray, X-ray, UV ray or visible ray, if you consider any beam of radiation, that beam always consists of multiple photons, and all the photons traveling in only one direction, that is in a direction along a straight line like this. Billions of photons together pack, that is a ray, a beam, it takes a, that is called a ray or a beam of radiation. And so whenever I talk about this visible radiation, that is the one we have to concentrate. The radiations of this wavelength is of quite interesting, and we have an organ, that is an eye, very important organ, which has some biomolecules which are specialized for biomolecules. Some biomolecules in the eye are specialized for sensing of these radiations, sensing of the radiations having this wavelength. But they don't have sense of this, recognizing this or sensing this like this. That is the only, that is biological cells, that is a God gift. And these radiations are not harmful. Just sense when the radiations they absorb those biomolecules, that is biomolecules are there, simply absorb and give the sensation to the brain. There is a light sensation or recognize the light. And if you talk about these radiations, they can pass through. And what is that? These radiations will cause damage to the cell. The reason these radiations have energy, that is a photon of energy of this or this, have sufficient amount of energy to break the chemical bond. What chemical bond? Chemical bond of biomolecule. They can break the chemical bonds of biomolecules, and every cell is composed of a variety of large number of biomolecules. The functioning of biomolecules gives a specific function of the cell. So when the chemical bonds are break up, produces undesirable products. When these radiations pass through the cells or organ, produces undesirable products, leads to cell damage, even cell death. That is why these radiations are dangerous radiations. But these radiations are less energetic and they don't have sufficient energy to break the chemical bond. But these radiations have a sense, are getting sensed by the cells. But these radiations are not sensed, that is not getting sensed. Those cells cannot sense or recognize these radiations. This is one sense. That is the nature. So that is what we talk about. These visible radiations plays an important role for our visibility. So our eyes will sense the radiations. What radiations? Visible radiations or light radiations which are getting reflected from the objects, on the surface of objects. That is the reason we see the objects, the size, the shape and color. So what size it would be, what would be the shape, what would be the color. It is all by the eye capturing the light reflecting from the surface of the material. That is sensation. That is the reason why we see the objects in our surroundings. The variety of objects, there are different solids, plants, animals, earthy materials, water, or gaseous, that is some gases, colored gases. They are all what is that visible to us. We see the things around us and we are aware of what things they are. It is all depends on mainly the visible light passing through our eye. That is a God gift. That we are making study on this visible light. So now with this introduction, let us move on to the study of optics. Optics is further divided into two types, that is ray optics and wave optics. What is the difference between the ray optics and wave optics? In the scientific study of ray optics, we use, that is, the mirror, lens, prism through which the light is allowed to pass and then study. The light is allowed to pass and then study. So these are the objects are using whose dimension, the size of this mirror, lens and prisms are very much larger than, are very much greater than wavelength of the light. That is the difference. Wavelength of the light. And the study involves it is image formation and the relationship between the image and the object. Image produced by the mirror or lens and the object, the relationship, the size and the nature of image using the geometry, the knowledge of geometry using the ray of light. The ray of light always consists of, you see, billions of photons, that is a beam of light. Using this study, using the geometry of this ray object, that is ray of light, geometrical drawing, geometrical knowledge, we are going to assess what would be the kind of image formation and the relation between the image and the object and the radiations, how the way the rays are distributed, and finally with the result. On the basis of that is the study involving that is called as ray optics. What is wave optics? In wave optics, we take what is the object, that is a slit or hole. What is slit? Very narrow slit or a hole, the hole of extremely small in size. What would be the dimension? The dimension is comparable, almost comparable to the wavelength of the light. That is the size of the slit or size of the hole. Almost it is comparable to the wavelength of the light through which we pass the light and we look at what kind of the light after the light passing through that object. That is a study involves wave optics, and what we view, what we get in geometry or something like that after passing through, it is completely what is that related to the wave property of light, because I said wave, electromagnetic radiation is a sinusoidal wave. That study gives us or characterizes the wave nature of the light, completely wave character. That is example, diffraction, polarization, interference, like this. There are properties, exhibit the properties of wave or light. So where we make a study details about this called wave optics, and is called as ray optics. Now let me brief about the ray optics. In the ray optics, always we take a beam of light, a narrow beam of light. It is called as a ray of light. When I talk about the ray of light, it always consists of, I say that photons, not in few, it is in billions of billions. So this ray of light consists of photons. All the photons are only in one direction, traveling in only direction, beam. That is a ray of light. And in the ray of optics, mainly we are talking about the reflection and refraction. Reflection means is going back, bounces light, bounces back. Refraction means pass through with deviation. That is called refraction. So what is reflection? In brief, I call, because I already made a study a lot in the high school level. That is, a plane surface is there. I am taking a plane surface. It is polished on one side, it is opaque this side. This side is produces reflection. So when a beam of light or ray of light is made to fall on the surface like this with an angle, it is bounces back like this, deviation like this. At this point is called as point of incidence. So this point, at the point of incident, let us draw a straight line perpendicular to the surface. This straight line perpendicular to surface is called as normal. That is normal to the surface. And you see that a different angle, that is the surface of the material, that is the incident ray. After that it's reflected in this direction. This is called reflected ray. It is called as incident ray. The ray is bounces back in this direction. The angle between this line and this surface is called as theta. It is called as glancing angle of glancing. And the angle between this line and this line is called as angle of incidence, normal and incident ray, I. And the angle between this line and this line is called as angle of reflection, R. On any surface, we see the reflection like this. This angle is always equal to this angle. There is a law of reflection. Angle I is equal to angle R. Any surface, whether plane surface or any kind of surface. And on the plane like this, the ray of light is supposed to pass through the material like this, but it is getting deviated from this path to this path. It is reflection. And the angle between this line and this line is called as angle of deviation. That is, the ray is deviated by this angle because of this material. Angle of deviation. So look at this angle of deviation. The angle, that is total angle, that is the angle is 180 degree. It has to pass through like this. There is no objection. What is the objection? There is reflection. But deviated by what angle? This angle and this angle are equal. It is 2i or 2r. Therefore, 180 minus this angle gives the angle of deviation. So, D stands for angle of deviation due to reflection. What is the angle of deviation due to reflection by the surface? It is called as angle of deviation. And one more I need to stress upon, between this ray and this ray, it is called as incident ray, it is called as reflected ray. What difference? Here the velocity of the light remains same, no change in velocity of reflection, and even wavelength of all the photons, see that no difference. If wavelength remains same, frequency also same, because frequency and wavelength are interrelated like this. Wavelength, no effect on the wavelength or frequency of reflection, or no velocity difference, same velocity bounces back. But difference, we are finding intensity of the ray. Intensity of the reflected ray is always less than this incident ray. The reason, intensity, of course, is maybe little or bigger, depends on the material. The reason here, after the incident, that is at the site of reflection, some of the photons of light are getting absorbed by the atoms or molecules of the material at the incident ray, and of course getting converted into heat or something like that. Absorb. Some photons are getting absorbed or being absorbed, and some photons are getting scattered by the atoms or molecules at the point of incidence. That is, there are some group of photons are there. Some photons, very few photons are getting absorbed by the atoms or molecules at the site of the material, or getting scattered. Sometimes scatter means change the direction. Suppose to direction like this, change the other direction. Scattering. Some photons are getting scattered away from this point. So those photons are missing. As a result of losing some photons, intensity decreases, because intensity depends on the number of photons which are carrying through the line. That is the reason. Intensity of the reflected ray decreases. That is, all velocity, wavelength, frequency remain same except intensity. So in this case, I have taken the plane surface. However smooth surface may be, it is still not a perfect reflector. Any surface, take whichever the smooth surface, it is still not the perfect, it is not still a perfect reflector. No 100% reflection. It is because of, I said, absorption of some photons and scattering of photons at the site of incidence. It is due to the molecules or atoms of this material. That is what I want to stress it upon. This is about the reflection of light. That is a brief introduction. We shall continue in details in the next class, in the next session. Thank you with this.